Okay, so good day to all of you. So in this video tutorial, I'm going to show you how you're going to use a temperature sensor in your simple Arduino project. So, what are the materials that we need? But before that, so in the market, there are various temperature sensors available. So here I have three. So we have the first one. We have this called a thermistor. Thermistor is the cheapest as far as I'm concerned with these three temperature sensors. So this is used for detecting overheating of appliances. Actually, this is a component in the electric fan. So a thermistor. And then we have another one. We have the so-called TMP36 sensor. So this is the other. It has 3 pins. And then a more sophisticated one is we have the DHT11, or the so-called temperature and humidity sensor. So the two temperature sensor that I have showed you, they only measure, of course, temperature, but this sensor measures also the humidity. But in our video tutorial, we're going to deal with the TMP36 temperature sensor. So this is our TMP36 sensor. So as you can see with our TMP, so the side is flat, and then we also have this curved side. So why is it created like this? So that we can remember the configuration of the pin. Okay? So TMP36 sensor, its pin has polarity, unlike with push button. You're just going to assign your source and your ground, and then of course proper configurations for your pin. But for this TMP36, so we have to make sure that, for you to remember, you have to make sure that the flat side is facing you, and then of course this is our 3 pins for the sensor. So this left side, you have to remember, this is for our power source. And then the middle, so TMP36 sensor, unlike LED and push button, LED and push buttons are digital. Why? Because LED is on and off, whereas push button is also has a state of on or off. TMP36 sensor, since it captures the room temperature or your temperature, your temperature, so it needs analog pin. You cannot connect it, or it's not that you cannot connect it to the digital pins. You will have an accurate result if you're going to connect it to the analog pins, which is from A0 to A5. And then this the rightmost pin, of course, since this is the power source, then this should be connected to the ground. Okay, so it's only 3. Again, this is for the power source. This is for your pin to be assigned. And then this is your ground. Okay, you have to remember that, because if you're going to set it up right, you have to remember the proper configurations, because TMP36 sensor has its pins polarity. Okay, then we need, of course, a set of cables or DuPont cables. Again, of course, we need that. And we have our Arduino Uno microcontroller. So let's start setting up our TMP36. Okay. So let's connect our TMP36. So you can connect it here, but for more space, you can... Okay. You can see it's already connected. Okay, then again, you have to remember that this side is your power source, since this is the flat power source, your pin, and then your ground. Okay, again, let's assign for the power power rails. Okay, so we have, okay, let's connect it to 5 volts. And our ground, of course, to ground. Okay. Maybe you have a question, can we directly connect our wires going from here to the ground or to the power source? Actually, it's just okay if you're using one component only, but if it's a good practice already that you're setting up this way, so that when you when you have many components, you just need to connect your power source and the ground in the railings. Okay, so it's already, we're already practicing that we should set up our power source and the ground in the railings. Okay, next is, of course, again, our most left side for our temperature sensor is our power source. So this is where our power source is connected. Power source. Okay, these are all these points are all owned by the power source. So anywhere, it's important that it's aligned. Okay, and then our middle, the middle is, since it is an analog input, so we have to put it where? So we cannot put it in here because you won't have a precise result. So we need to put it where? So we need to put it in here from A0 to A5. So since this is an analog device, so let's put it in A5. So let's set up for the pin, the middle, and then connect it to A5. Okay, for our analog device. And then lastly, our ground, the rightmost part or the rightmost pin. Okay, and then connect it, of course, to the ground. So this is actually already our setup for our temperature or TMP36 sensor, to be specific. So now we are already ready to code the corresponding functions or the Arduino sketch for our temperature sensor.
Okay, now so we're ready to code our Arduino sketch for the TMP36 sensor that we've set up in the breadboard with the Arduino Uno board. So let's start by defining the pin that we have used. Okay, so we have number sign define TMP underscore pin, and then we have, since in the electronic component setup we have chosen A5 as analog pin number 5 because TMP36 sensor is an analog input device. Okay, actually in our presentation we have 5 only. Actually, there's no difference. It's just that what if your project has become complicated and you've used a digital pin number 5? So, it's the reader or the one who will going to scrutinize your Arduino sketch will be confused. So, for clarity, so let's really declare that since we've used analog pin number 5, so we have to put letter A in here. Okay. Since in our example, we want to display the temperature in Celsius and in Fahrenheit. So to display the text, again, we're going to use the serial.begin, and then the baud rate is 9600. Okay, so this is the only line of code that is needed for this one. So let's proceed with the void loop. So we have int pin value is equal to analog read temp underscore pin. So what does this line of code mean? Since we have a function of analog read, meaning it will read the analog signal or the analog value that the pin has. So actually analog read has only one parameter, which is the pin in which the analog read will get the value. So the value where the analog read will get is from temp pin, and whatever the value that the TMP36 sensor has acquired, it will be stored in pin value with data type of integer. Okay, then next is we already get the value of the temp pin. Next is we have double voltage is equal to pin value times 0.0049. Okay, so what's the meaning of this line of code? Okay, you've already acquired the value for pin value. So in order to get the actual voltage is you will multiply the pin value by 0.0049. So where does this 0.0049 came from? It came from, since our power source is 5 volts, we're going to divide it by 1024. So by dividing it, you will get this value, the 0.0049. And then if you're going to multiply it to the value that is acquired by pin value, you will already get the equivalent voltage. Okay, since we already got the equivalent voltage for the temperature reading, we can already display it in Celsius. So we have double temp C. This is temperature in Celsius is equals to, we have voltage minus 0.5 and then times 100. So by having this formula, voltage multiplying 0.5 times 100, you will already get the temperature in Celsius. Okay, since you already have Celsius, you can also get the value for the Fahrenheit. So temp F is equal to temp C times 1.8. Then after that is you have to add 32. So this is our formula for getting the temperature in Fahrenheit. Temperature in Celsius times 1.8 plus 32. So, after getting these values, we can already display the values by using the print ln or print. Okay, serial dot print, we have temp C. Okay, maybe you have a little question here. Why is it there's no ln? Actually, serial.print ln means we're going to print the value inside the serial.println function. And then after printing it, we're going to have a new line. It's like after printing, you're going to press enter and the other word will be displayed on the next line. Since it does not have ln or meaning line, so it will only print the value of temp C, but it will not go to the next slide as line to display the next value. Okay, so next is we have serial that print. Okay, so we have dash line, we have serial that print, we have the double quotes. Okay, why didn't we put double quotes here? Because this is already a variable for the temperature. So it will display the value that is stored inside temp C. So if you're going to put here a double quotes, meaning what you're going to display is the actual word temp C, not the value. So just remove our double quotes. Okay, next is we have serial dot print, and then since this is temperature in Celsius and then we have a dash, so next is temp F. So to display the corresponding temperature in Fahrenheit. And then we have a delay of 2,000. Okay. So, in order to print new line, so we have to put ln so that the next set for temperature going to temp F will be printed in a new line. Okay, let's run this Arduino sketch, or rather, let's verify or compile. So let's name it TMP36, just to name that it is using a TMP36 sensor. And let's see if we have any errors. Okay, we do not have any errors. Okay, thank goodness. Okay, so this is the code for using temperature sensor, but without using any structure. We have another version which we are using structure. So let's have another one. Okay, let's create new so that we can create a code. Actually, the output is just the same. It's just for this part, we're going to use the so-called structure data type. Okay, we can copy actually if you're already, for example, you've already have an existing Arduino sketch, and then you're just going to modify it. You can do so by just copying it. So we've already copied. So what we're doing now is we're going to create a code with the same functionality. It's just we're using structure to demonstrate it to you. Okay, for this code, so we're going to declare a structure data type. So its keyword is struct. And then let's name it TMP underscore 36 underscore reading. And then we have this left curly bracket. And then for structure, we can store different data types, and it can store value all at the same time. That is the difference between union. Union you can also declare different data types inside it, but if you're going to display its values, it will only display once, specifically the last. It will display correctly the last call that you did for union. So we have double voltage, and then we also have double temp C, and then double temp F. Okay, we've declared. And though structure uses curly brackets, because this is still a data type, unlike if and for, which have curly brackets, since it's a data type, you must put a semicolon after its right curly bracket. And then also, it's just the same without the Arduino sketch that does not use structure. We have serial.begin, just the same functionality. Okay, next is we have, it's just the same also. We have int pin value is equal to analog read, then temp underscore pin. Okay, so since this is from the code which does not use the structure, so we're going to declare another variable. So let's declare so that we are going to call the structure data type. So from here, so let's declare struct TMP36 underscore reading. Okay, so then we have temp. So what does this line of code mean? Meaning, since you've declared a structure here, you're going to use this structure. So we have also the name, the TMP36 underscore reading, and you're going to provide your own variable name for calling the structure TMP36 underscore reading. So our name here is temp. Okay, next is we're going to modify this one. So how are we going to modify? Since voltage, temperature in Celsius, and temperature in Fahrenheit is already declared in the structure, we just need to call them by using the variable name that we have used for calling the structure TMP36 underscore reading. So what will happen here is, what is the name of um, the variable that calls struct TMP36 underscore reading is we have temp. So let's type temp, then dot voltage, meaning this is the variable name of the structure which uses the TMP36 underscore reading. Then we also have to have this point so that we can access the data types that are, or the variables that are declared inside the structure. So we have temp.voltage. So we have to change again the temp C, since it's a part of our structure, temp.c, and then voltage, of course, is we have to put temp.c, temp.voltage. So what will happen here? What if you do not put voltage? You will have an error because actually voltage is declared inside structure. If you do not put temp.voltage, the compiler will look for where did you declare the data type or the variable voltage. So we have to put temp.voltage, and also temp.f, since it's part of the structure, temp.f, and then of course temp.c is inside the structure. We have temp.c. And then next is we have created a function so that we can display this separately. So instead of this one, we can cut this one, and then okay, we can just leave it there. And then we will have a function here which is, okay, we have void show temperature, and then by using the structure TMP36 underscore reading, and then temp. Okay, so okay, let's cut and paste again these lines of code. Okay, then paste. Okay, we have serial.print temp C. Again, let's change it into temp.temp C, and then also the temp F to temp.temp F. Okay, we created our custom function. We only separate it into function acts like module so that the main body will not be too long. So it will make your code more readable because you separated the codes into functions. So our function is show temp. So in our old Arduino sketch, before delay for 2 seconds, it will display the temp C. Since for this example, we've already have a function, a customized function that we did. So we have to call the function show temp, and then the parameter is temperature because this contains the values for voltage or temperature in Celsius and temperature in Fahrenheit, and then this will be used to display the specific function. So let's see if our code has errors or not. So let's verify. Let's name TMP36, then let's put struct, meaning this code uses a structured data type. Okay, let's see if we have errors. Okay, we do not have any errors for our code. Okay, so since we've already created, so this version does not have a structure. What you can notice is that, of course, uh, the the Arduino sketch with a structured data type has longer lines of code. It uses specific 30 lines, while your TMP36 without structure only uses 18. So which is which? Actually, it depends upon your preference. It's just that its structure is, this is very useful because you can combine data types that are really are in they are together, such as this one, TMP36 underscore reading. So the data types here are related to one another. So that's what's good with the using structure. Your data types and your variables becomes meaningful because you can group them and then you can name it whatever usage is that. So again, but as a programmer, if you are more comfortable here, less lines of code, it's just fine. But example, if you are requested, for example, to use a structure, of course, you should know how to do it also with a structure data type. So we've already finished with our electronic setup, and then we've already finished with our code. So now we will see if these two lines of these two Arduino sketches rather are going to work if we're going to upload it in the Arduino Uno board. Okay, so we're now ready to upload our Arduino sketch for TMP36 sensor. So first we're going to upload this sketch without the structure data type. So, but before again, we have to check if we already have configured properly our Arduino board to our computer. So, and then it's in comp number 5 port. Okay, let's upload. Okay, so we finished uploading. So let's see our serial monitor. So our serial monitor displays actually the room temperature. So it's a little bit, it's not hot today because of course here in the Philippines it's raining. So this is the room temperature, okay, that the TMP36 is getting. So this is the Arduino sketch without the structure data type. So let's close the serial monitor and then let's see the other Arduino sketch with a structure data type. Of course, we haven't changed anything, even the formula. So we will get just the same temperature. And because we just, that's the only difference is that we just use a structure data type. So let's upload this other um, Arduino sketch to see what's the effect, or are they just the same? Okay, so it's also successfully uploaded. So let's see the serial monitor. Okay, as we can see, there is no difference between the readings of using a structure data type and an Arduino sketch that doesn't use a structure data type. So it just means that disregarding your code, if your output are just the same for two Arduino sketches, you just implemented it because the first is implemented without a structure and another is again with structure. But since their functionality is just the same, you can expect that their output will be just the same. So this only demonstrates that as long as they have the same requirements for output, disregarding what is your preference in coding, you will still get the same expected result. So, I hope with this tutorial, you've learned something about the TMP36 sensor, to be specific. But other than that, there are also temperature sensors available in the market. And then you can also code your Arduino sketches, may it be with a structured data type or without. It depends upon the programmer's preferences. But if you are required, of course, to know how to code with structure, so you should also know how to make or declare a structure data type. So if you do have any questions, feel free to comment below. And if you do not have any questions, so thank you very much. I hope that you will subscribe to my channel and see you in other learnings and other videos that I'll be sharing. So again, thank you very much and good day.